Hello everyone, so welcome to my YouTube channel videos again. My name is Andy, and today I will make a homework walkthrough video for section 5.1, which is like Riemann sum approximation. With this section, we haven't now learned an integration technique yet, or any advanced approximation yet, so we heavily rely on the right endpoint approximation, left endpoint approximation, and the midpoint approximation. So if we have a complicated function, whether it's complicated or easy, when it's giving like, so what you're looking for is the interval, how many subintervals, and what approximation that they're asking for. And if we denote the function from x equal to a 0 to x equal to 24, and a is just the starting point of the interval, and b is the end point of the interval. So for this question, a will be a 0, b will be a 24. How to do left point approximation is like, if you want to do 8 subintervals for this question, so each width is going to be 3. So do from x equals to 3, 6, 9, 12, 15, 18, 21, 24. And how to do the left hand point is like you pick like the lower end of each subinterval. So lower end of each subinterval. So we go from x equal to 0, 3, 6, 9, 12, 15, 18, 21. 8. That is 8 subinterval for left hand point. You want to do the midpoint is take the middle of the each subinterval. So we do 1.5, 4.5, 7.5, 10.5, 13.5, 16.5, 19.5, and 22.5. Writing the fraction form, it is 3/2, 9/2, 15/2, the 21/2, 27/2, 33/2, 39/2, and 45/2. If you want to do the right endpoint, it's like the upper end of each subinterval. So we do 3, 6, 9, 12, 15, 18, 21, 24. And what is the behavior of each, like the approximation depends on the behavior of the function. If the function is decreasing as x increase, then usually the right endpoint is underestimate. The left endpoint approximate is always overestimate. The midpoint usually have the highest accuracy to approximate each integrals, and it is like the best approximation if we do not integrate the function, but we can just say, okay, here's like the nearest the value of the function over this interval. And now I want to point some like question. So like this is a decreasing function over the interval. So left endpoint it is overestimate, right endpoint it is underestimate. Number 3, so we have a speed of a runner. It's like this table. You want to lower estimate this means. And first we want to figure out like the behavior function. So this is x and y. As x increases, y increases. So this is an increasing function. If the function it is shows increasing behavior, then the left endpoint is usually underestimate and the right endpoint is usually overestimate. So for this lower estimate, this means like the left endpoint approximation. So we take 0, 6.7, 11.2, then just by 6 subintervals, and we just first 3 seconds here. So for smaller value, we do L6. For upper estimate is like this is increasing function, so we want to do the right endpoint approximation. So we do R6, just doing computation for here. First 60 seconds, we give it a table here. And this is also increasing function behavior. The upper estimation, we want to reach the right endpoint approximation. You do not need to find how many subintervals here. You already gave here 1, 2, 3, 4, 5, 6. There's 6 subintervals. You only need to do R6 for our upper approximation. Okay, now we're writing the function into like a sigma notation. As we know, like b minus a over n, it is the width delta x, and the each subinterval is going to be a plus I to the delta x over n is like each subintervals. So for this pieces, we want to write into like a Riemann sum form, and we will try to write the notation. And you want to form two things. Xi is going to be a plus I x over n, and now it's going to be x is going to be and now we just try to x as a plus I times delta x, and for delta it is a width, and now I it is going to be the lower bound of interval. And now we're back to function is a 4 to the 6. So that weight is a 2 over m. So no matter how many interval you put, the weight is a 2 over m. And the function is going to be x. Function is going to be xi. So here's xi is going to be 4 plus. So it's going to be 4 plus I to delta x. So it's going to be 4 plus I. 4 plus 2i over n, that is going to be actually the ith interval or like subinterval pieces here. So if we write the notation, it's going to be the delta the width, make sure to multiply entire function notation here going to be 2 over m. And then times going to be, we have this x squared, so it's going to be 2i over n to the square, then plus the square root of 1 plus 2 over 2i over n, and that is the x, and that is the notation. F number 5 is going to be the pi over 5, and this is the interval. So it's like the interval is a pi, so it's b minus a. So number 7 here is b minus a, it is going to pi. And then always just to make sure that it is okay, it's going to be pi over 5. or is it going to be tangent over I over pi 5n? So this is the width, and this is x. Actually, so it's like not x. So not the first one, not the last one. So this is the width, is x over delta x. Like a b minus 8 is a pi over 5. So actually, the interval is going to be from any interval b minus 8 is pi over 5. So we eliminated the third one and the second one. Because the 5 pi, this is because like make sure because like pi over 5n can be rewritten by pi over 5 times the 1 over n. So this could be like the fourth one, because this is going to be tangent of x. The first one, this is the width. This is going to be the real x. Number 8 is going to be the y to the x to the cubic from 0 to 1. So like the b minus a over 1 going to be 1 over m. The xi is going to be a 0 plus I times the width. So it's going to be I over n, because the 1 it can be written as 1 times I. So limit is going to be 1 over n times I over n to the cubic, and make sure put the parentheses in the right place. I want to reiterate, it's like the xi interval is going to be a plus I times delta x. So if you find the delta x, then just multiply, and this is your xi, and the limit and the Riemann sum, and Riemann sum like notation going to be limit to n approaches the infinity, and then it's going to sigma n bottom I equals 1 f xi times delta x. So there are two different parts. The fxi is your function part, and the delta x is like the width. And I will have the handwritten homework guide by tonight will be available. Here's like video walkthrough of my homework problem. I hope this is helpful, and good luck on doing this homework. Thanks so much for listening, and have a great day.